Okay, dear student, let's see how to do this question. Source X and source Y both emit waves of the wavelength zero point 0.4 meter. There is a constant phase difference of pi between the sources. Okay, there have never been this kind of a question earlier in IB physics. So this is first time I'm doing this kind of a question for IB. Okay, so this is going to be different. Be very careful. The point P is 5.2 meters from X and 4.6 meters from Y. The amplitude of each wave is A when it reaches P. So the amplitude here is A and A. What is the amplitude of the resultant wave at P? Okay, dear students, so listen to me. Till today, till now, what we did in the case of interference, we always have taken the phase difference to be zero when they initially started at the point X and at the point Y. So the phase difference was zero earlier. Now, what do you mean by that? It means that when the wave is starting with Y, let's say it starts with the crest and the trough. Now, if the phase difference is zero, even at X, they are starting with the crest and the trough. So this was the usual case which was happening till today. But now onwards, that is not the case. Now it is given that the phase difference is pi. It means that for X, when the wave is starting, it is first a trough and then a crest. Be very careful. This kind of thing is not given in the books. This thing is not given anywhere. And IB has just given you a surprise with this question, okay? Even like I have never done this kind of a question in IB physics first. So this is what is happening. Now let me explain you what a coherent source is, and can these two waves which are having a phase difference of pi instead of zero, can they undergo interference or not? So there is a topic of coherent sources, and IB does ask question on coherent sources in paper 2 and others. So please listen to this. Two sources which are having the same wavelength or which are having the same frequency, only those sources can create interference. There are some conditions that have to be fulfilled, otherwise interference will not happen. So the first condition is that the two waves which are interfering, they should be the same wave. They should have same frequency, same wavelength. So that is condition is satisfied here because the source X and Y both are emitting the wavelength with 0.4 meter wavelength. So that is done. But there is another condition that is on the phase difference. Now the phase difference should be constant. Now that is the condition. The condition is not that it should be zero, that it should be this value particularly, but it should be constant. It should not be variable, like now it is zero, now it is pi, now it is pi by 2. No, not like that. So in this question they have written pi, so that is perfectly clear, no problem with it, but it should be a constant value. So it is a constant value, that is pi. Now, so these are coherent sources, interference will take place. Now let us move to the question back again. So when I see these options, first of all, I can clearly cut B and cut C. Why? Because in IB physics, in your syllabus, there are only two cases which are taught to you. One is constructive interference, another is destructive interference. If tomorrow they tell you that there is another formula here, like that is not covered in your syllabus, I can give you that formula. But if that is not covered in your syllabus, these answers are not possible. So for this time, B and C are wrong. They are not the answer. I can give you the formula here, by the way. The resultant amplitude will be given by this. If ever you need this, and this is cos phi, the phase difference, the initial phase difference, for example, in this case, it was pi. So we will be substituting this value pi here, and you can find the resultant amplitude at this point. But that is not in your syllabus. Be very careful. Now, so let us imagine that B and C are not in your options, so only A and only D is there. So either there will be destructive interference or there will be the constructive interference. So we have to find the condition whether constructive interference will happen or the destructive interference will happen. Now, usually we use this formula for the constructive interference, that delta X is equal to n lambda. This is the formula for constructive interference, very usual. But in this formula, there is one condition. Both of the waves should be starting with zero phase difference, which is not the condition in this. So how can I do that? So because of the initial phase differences, there is already a path difference. Now, I'm going to the second part of the video. Be with me. Now, the initial phase difference is given. So okay, one path difference can be found, like 5.2 minus 4.6 is one path difference, so it is 5.2 minus 4.6, plus there will be additional path difference that has to be added into this equation because of the initial phase difference. Now what that will be, so that will be, um, you can say, I'm using this formula, delta x is equal to, or delta phi is equal to 2 pi by lambda into delta x. I've given you this formula many times now. So we would be finding delta x because of this. So delta lambda divided by 2 pi into delta phi. So the phase difference is given as pi. I substitute this value. So this pi and this pi gets cancelled out. It is coming out to be lambda by 2. So lambda by 2 is there. So I have to substitute lambda by 2 here, and then it will be equal to n lambda. So this becomes the condition for the constructive interference to happen. Now overall, if you think this lambda by 2 can go to the other side, it will become n minus half, which actually corresponds to the destructive interference condition. So in this particular case, the destructive condition will become constructive and constructive will become destructive. Why? Because we are having a phase difference of pi. That is why they have shifted. So both of them, they are swapped. But I don't want to confuse you, so we are not going into that. So you can just understand this thing. In IB, I don't believe that you would be getting a path difference which is different from either 0 or pi by or lambda by 2. It cannot be other, like lambda by 3. I believe IB will not be doing that. But nobody knows it. So we move with this. So 5.2 minus 4.6 plus lambda is 0.4 divided by 2, it becomes 0.2, which is equal to n into lambda. Lambda is again 0.4. So we want n to be the integer. If n is an integer, it will be constructive interference, otherwise it will not. Let us solve this condition. 5.2 minus 4.6, it becomes for 0.6 plus 0.2. So this is coming out to be 0.8, and which is equal to 0.4 times n. So clearly the n value is coming out to be equal to 2. So n value is 2, which is an integer. And like it could be any integer, 1, 2, 3, 4, doesn't matter, but it should be an integer. If it is an integer, constructive interference is taking place, and so the answer will be 2a. So first of all, I found the total path difference between the two waves, and I equated it with n lambda, simple, and I found it to be 2a. Now this is really a long process, but this is exact process that you should be actually doing. But provided it is IB and we are not going into that much of the details. So if ever the phase difference of pi exists, you can even create a shortcut here that the destructive interference condition will become will be used for constructive, and constructive condition will be used for destructive condition. Is that clear? Um, I can even do that. This is a very different question, so let me please do it and just see it. Let us try. So for the destructive interference, usually we take delta x is equal to n plus half lambda in IB, but it could be n minus half also. That is not a problem. So let us see if n is coming an integer here or not. So n, so delta x will be 5.2 minus this, which is 0.6. N plus half, and lambda is 0.4, so that can go to this side. Decimal gets cancelled out. It is 3 by 2. So you are subtracting half from 3 by 2. 1.5 minus 0.5, so n is coming out to be 1. This is an integer. Now you might be confused that what the hell is happening. See, this destructive interference is not including the phase difference of pi in its calculation. So this is valid and n is coming out to be equal to 1. But there is a phase difference of pi. So this formula, which is for the destructive interference, is no longer for destructive. It is now for constructive. This is what I was telling you. So this is the right method. please watch the video again and again, couple of times, like 4 or 5 times, to understand this, because this is the topic of interference C3. This topic is included in SL also in the new syllabus. So don't feel that this is difficult and it is not in your syllabus. It is in syllabus of every student who is watching this. So keep watching this video a couple of times, and then you will understand each and everything. Okay, dear students, so all the best. Thanks for watching. Bye. By the way, all the lectures for the topic C1 to C5, they're already uploaded on the YouTube channel, but you have to become the member to watch the lectures for the topic C3. You can help yourself. All the best.